Hello, I am Michael Black, Sales Manager Pharma at BENEO, and welcome to our podcast, Excipient Talk, brought to you by galenIQ. And today I am talking with Dr. Maj-Britt Cepok. So, hello, Maj-Britt.
Hello, Michael.
So, Maj-Britt, please introduce yourself to our watchers.
Hello, I am Maj-Britt Cepok and I am the head of Business Development Pharma at BENEO. And I have been working with isomalt for exactly 20 years now in food and pharma applications.
Okay, Maj-Britt, thank you. So, what are we going to talk about today?
Today we are going to speak about continuous manufacturing.
Okay, so what exactly is continuous manufacturing?
Well, traditionally manufacturing of pharmaceuticals has been done in a batch process, which means that you have single process steps which are separated and with pauses. And unlike this, continuous manufacturing integrates all stages of production into one seamless process, so being carried out in one single uninterrupted flow. And therefore powder feeding is very important in continuous manufacturing.
At BENEO, we manufacture galenIQ, which is a water-soluble filler binder that can also make medicine taste better. So what is the role of a filler binder like galenIQ in continuous manufacturing?
Yeah, indeed, excipients play a crucial role in continuous manufacturing because they should ensure the smooth and efficient production by a continuous process. For example, an excipient needs to be the same, no variability, every time so that they can be fed into the manufacturing process smoothly and also continuously.
All right.
Then the excipients help to mix the active ingredients and the other components uniformly. And during tableting, the excipients contribute to the compressibility and binding of the tablet. And they ensure that the tablets have, in the end, the desired hardness and disintegration properties.
Okay. So what is the benefit, let's say, of using galenIQ in a continuous manufacturing process?
Well, our agglomerated grades, which are galenIQ 720 and 721, they have a unique morphology. Then they have a very narrow and consistent particle size distribution. And they are specifically designed for direct compression. In addition, these grades ensure high blend homogeneity, which means they are resistant to segregation and they are very well compactable. So we assume that all these properties may be particularly relevant for continuous manufacturing.
Okay.
Where there is mechanically stability is required and materials need to be processed over a longer period of time.
Right. But have any studies been done?
We have investigated the suitability of galenIQ 721 in continuous manufacturing processes. And this means that we have characterized the volumetric feeding behavior under different process conditions, the powder adhesion to stainless steel surfaces, and also the tribo-charging propensity. And galenIQ has been investigated in comparison to mannitol.
Okay, so you mentioned tribo-charging.
Yeah.
Can you explain exactly what that is?
Yeah, tribo-charging is electrostatic charging, which means that it is related to generating an electric charge through friction when materials come into contact with each other and are then separated. That means that tribo-charging can for sure occur during feeding, where the particles have a collision with each other, and also during the process when there is a collision of the particles with the wall.
Right.
So it is a highly complex phenomenon, and it may lead to, if it occurs, it may lead to deviations in the mass flow, and also to adhesion of the powders on the stainless steel surfaces.
Okay, so the study was basically looking at the tribo-charging effects of isomalt, galenIQ, and in comparison with mannitol.
Exactly, tribo-charging effect as well as the feeding performance of both materials under different conditions.
Okay, and what were the findings of the study?
Well, to sum this up, galenIQ showed comparable feeding behavior to mannitol. However, with the big difference that galenIQ had a significant lower tribo-charging propensity compared to mannitol, and also a significant less tendency to adhere on the stainless steel surfaces and on the screw outlet, and So the conclusion in the end was that galenIQ 721 is a suitable filler and binder for continuous manufacturing DC tableting processes.
Okay. So is there actually a scientific explanation for the, let's say, better performance of galenIQ 721?
There are assumptions, and it was assumed that the better performance was related to the inner structure and also the surface energy, and which means that compared to galenIQ, mannitol has a more porous structure. It has a larger surface area and also has less surface water. So it is assumed that this leads then to the lower tribo-charging propensity of galenIQ.
Okay, all right. So have these results been published?
Yes, indeed, they have been published in the year 2023 in the 24th edition of the AAPS Pharmaceutics and Pharmaceutical Technology.
Okay, great. So then all our viewers can look that up and see the information themselves. So which further studies could be considered at this point?
We are thinking of further investigation of galenIQ together with active ingredients in the same setup. And in addition to that, we are working on the evaluation of galenIQ as a binder in twin screw granulation. Right. We have gained first results and they are very promising.
Okay, well that sounds very exciting.
It is.
So, first of all, thank you very much for sharing this information with us and for being our guest today.
Thank you for having me here.
Thank you. And also thank you to our audience for joining today. And we look forward to seeing you again in the near future. And we'll be bringing you more Excipient Talk. So, see you all again soon.